and 5.3, this is where we will start to add and subtract polynomial in 5.2. And in 5.3, we will multiply polynomial. But before we can add or subtract polynomial, let's go over the definition, or let's go over the terminology. I don't know if they ask you for the terminology, but let's go over terminology so that if I mention monomial, you know what monomial is. If I mention binomial, you know what a binomial is. So the first thing is the monomial. Monomial is basically tell you that it's a one term, one product, right? One term that is connect with a product. So as long as you multiply, as long as it's a multiplication, we call this one term. So we have 3x here, 3 multiplied to x. So if it's 3 multiplied to x, it's a monomial. It's just a one-term item, okay? I know there are 2 variables. There's a constant and there's an x variable. So there are 2 variables, but because it's multiplication, it's only one term. Over here, yes, I agree with you guys that there are 3 variables, right? There's a constant and -4. There's a y and there's a z. But because it's just multiplication, it's only one term. Altogether, it's only one term. So how can we know that the difference between one term versus 2 terms? Well, if we separate the term by addition or subtraction, then we say that now we have multiple terms. So binomial, bi meaning 2, so binomial meaning we have 2 terms. And as you can see, the 2 term we have here is 6x, that's one term, and a constant 8, that is another term. So 6x minus 8, that is 2 term, or 9x squared plus 11. So as long as they separate by addition or subtraction, then it's a 2 term. And if separate by addition and subtraction, add another term to our item, then trinomial will be, we have 3 terms, tri meaning 3. So as you can see, we have 4x squared minus 7x plus 12. That is one trinomial. Or we have 9y squared plus 11y minus 18. So as long as they separate by addition or subtraction, we will have another term, okay? So what if we want to add one more term? Well, we don't have a quinomial, ladies and gentlemen. After trinomial, we just sum everything up and we say polynomial. So anything more than 3, we just say that is a poly meaning many, polynomial meaning many term, okay? So we don't have a quinomial, we just have polynomial. And all of this thing here, monomial, binomial, trinomial, all of those things here, they all together as in a summary of a different polynomial, okay? It's just a summary of polynomial. And in terms of a polynomial, there are 2 items that they will ask you, I believe, on your homework is, what is the degree of the polynomial? Well, when you look at whatever item we have, for instance, in this case, if we look at this item, we say that this is a second degree, the highest degree among my x's, the highest degree, that is the degree of the polynomial. So if you look at this thing here, we will say that this is a second degree trinomial. If it's more than 3, we say it's a second degree polynomial, okay? You probably won't have a second degree polynomial. You only have a second degree trinomial. And up here, this will be a second degree polynomial, or vice versa. This thing will be a third degree monomial, okay? So the highest degree that will determine the degree of your polynomial. And the number in front of the highest degree is not the highest number. The number in front of the highest degree, that will be your leading coefficient. So for instance, this item right here, this item, the number 4, will be my leading coefficient. So the number in front of the highest degree will be your leading coefficient. In this case, number 9 will be my leading coefficient. This is -4 will be my leading coefficient. But again, the number, just the number in front of the highest degree, that will be your leading your leader, right? Your leading coefficient. And here comes 5.2. And the reason why earlier I told you guys that 5.2 is doable or is easy because it's basically the same thing that you've been doing. How do we add polynomial or how do we subtract polynomial? To add polynomial or to subtract polynomial, basically all you do is you combine like term. Ladies and gentlemen, that's all you do. In short, you just combine like term. You see what is your like term and you add the coefficient, you add the constant. You kept your variable, you just add the coefficient. Meaning if I have 7x added to my added to 9 more x, in total the 7 and the 9, I will have 16x total. So you just take the coefficient, you take the number, you add them up and you cap whatever your x is or your y or your z. Okay, so in short, that's all that we will be doing. You know, they changing the terminology. Yes, they change the terminology to become adding polynomial and subtracting polynomial, but the concept or the math that we will be doing is you combine like term. Okay, you combine like terms in that item. So let's take a look at this material. Let's take a look at this material. Let's say if I give you, or let's see what kind of problem we have. So my problem or example one, as you can see, example one, they tell you perform the operation add or subtract. And you will see that A, B, and C, A, B, C, and D is basically tell you to add the polynomial. So if you look at A, let's focus on A first. If you look at A, you can see that we have a binomial, right? A binomial two-term, a binomial added, or in this case, we have a binomial added to a binomial, right? Two-term added to two-term. So if you look at the previous item that I mentioned, for addition, all we need to do is drop the parenthesis, because addition, if you drop the parenthesis, it does not change or affect your item. So in short, this is all we need to do is we just drop the parenthesis and say 6x minus 12 added to 9x, 6x squared minus 12 added to 9x squared minus 14. And if you look at this item, your x squared and your x squared is your like term. And that is all we're doing is we take the 6 plus the 12 and not the 12, the 6 plus the 9 to give me 15, bring down my x squared, and the negative 12 and a negative 20, negative 14. Do you see that negative 12, negative 14? This thing will give me a negative 26. And that is all there is. That is all there is in terms of adding polynomial. Yes, they changing the terminology. Instead of say combine like term, they say add the polynomial. And again, the terminology is changing, but the operation or the concept, hopefully you guys see that is very identical to the previous material. You know, and the follow-up question they can ask you is what kind of degree of this polynomial? Then we will say, well, this will be my second degree binomial, and the leading coefficient will be 15. 15 will be your leading coefficient. This will be a second degree binomial. Okay, so that's the terminology that you will probably will see. Let me do B, and then I will ask you guys if you have questions, because addition should not be a problem. For subtraction, there is quite a little bit problem that we need to deal with, in the sense that because it's subtraction, before we can drop the parenthesis, we need to take this parenthesis and take this negative sign and distributive to the second parenthesis. Or in short, whatever in your second parenthesis is, the sign in your second parenthesis, they have to change. So up here, because this thing is positive, so I can just drop the parenthesis in the first item. But because of a negative or because of subtraction, I cannot drop the parenthesis. Basically, I have to distributive the 1 in. Negative 1 times 9 will give me a negative 9x, and a negative times a negative will give me a positive 8. So if you look at the previous slide, I tell you that in order for you to subtract polynomial, we need to use the distributive item, which is we have to distribute the negative in, or to be in short, how many ever term in the second parenthesis, you need to change the sign for that item. Once you change the sign, hopefully you guys see that my like term, what are my like term? My like term is my x. In this case, I have 13x, subtract 9x. And what is 13 minus 9? 13 minus 9 to give me 4, bring down my x. And the other one should be easy. My other like term is I have a 2 added to 8, and 2 added to 8 to give me 10. So my answer will be 4x plus 10. And this will be my first degree, because reminder, anything by itself is basically raised to the 1 power. This is the first degree binomial, and your leading coefficient will be 4. Okay, so this is what we have. And if you look at A versus B, the only thing different between A versus B is in A we have addition, and in B we have subtraction. If it's addition, you just drop the parentheses, it does not affect anything. But if it's a subtraction, we need to change the sign in the second parenthesis before we can drop it. Okay, so in short, hopefully you guys see or connect this to chapter 2. In short, in order for you to add or subtract polynomial, all you need to do is combine like term, but we need to change the sign before we can combine like term if we subtract. Question with A or B here. And if you look at for C, if you're looking for C, same thing go or same idea, you recognize, hopefully you recognize that we have a minus or we subtract. And to subtract, we need to distributive this negative in. And you have to be fair, ladies and gentlemen, you have to change the sign for every single item. You do not just change for one and not the other. And the careless mistake a lot of students do is they just drop the parenthesis without changing the sign. So make sure you change the sign. So in the front, there's no sign in front of this item, is assumed to be positive. So I can say that I have a y squared minus 11y plus 19. The first parenthesis doesn't change. The second parenthesis, I have a negative 8y squared. A negative and a negative become a positive 7y. A negative and a positive will become a negative 2. So basically, if you see, all we're doing is we changing the sign for every single item in your parenthesis. If it's positive, it's become a negative, negative become positive, and a positive become a negative. And once you have that, if you in doubt, and a lot of students, if you in doubt, if there's no number in front here, if you in doubt, you can always put a 1 there to make sure that you have 1y squared and a negative 8y squared. That is my like term, my y squared and my y squared. And in this case, 1 take away 8, a smaller number take away a bigger number, I still have a negative 7. And again, I just bring down my y squared. About to say 1 minus 8 will give me a negative 7, right? Same side we add, opposite side we subtract. And when we subtract and kept the sign of the larger number. Same idea go, my y, I have a negative 11y and a positive 7y. And again, a negative and a positive, I have to subtract. I have 4, bring down my y because 11 take away 7 will give me 4. And what is the sign of this 4? Well, this 4, because a negative is bigger in terms of the value, I have to put a negative 4. And lastly, hopefully you guys see that lastly, what do we have? We have 19 take away 2. And 19 take away 2, very easy or very doable. We will have a positive 17. And this, ladies and gentlemen, is our answer, because the y square and the y, they are unlike terms. You cannot combine them. The other thing I want to point out is whenever you add or subtract polynomial, your degree do not change. Remember, how or when does your degree change? They only change if you multiply. Remember, when do you add the exponent? When you multiply the two. When you multiply, that's when your degree changes, right? We increase it, we add them together. But when you add, when the operation is addition, you do not change the degree. You just combine like term. And if the follow-up question, they probably ask you what degree is this? This will be my second degree trinomial, and the leading coefficient will be -7. So question would C. Question would see in terms of how I derive to my answer, or what did I do to get to my answer. All right, if you don't have question with C, let's take a look at D. And hopefully you guys see that D is doable in the sense that because of this is addition, we don't need to change the sign for anything. For addition, you can just go in and say, well, you have a Z to the third and a Z to the third. Those are my like term, right? If that is my like term, what is 4Z to the third added to 8Z to the third? Well, 4 plus 8, that will give me 12Z to the third. Remember, the Z to the third and the Z to the third, we do not give it to Z to the sixth, because when you add them, you just add the coefficient, not the power. The only time you add the power is when you multiply, okay? So this is what we have. And again, like I mentioned in chapter 2, right? If you have $4 and you add it to $8 more, you do not have $12 square, right? The dollar and dollar, you do not square them, right? So the Z and the Z are, in this case, Z to the third, Z to the third, it does not increase it, okay? So the second thing we ask ourselves is, well, the next thing I saw is I have a Z to the second. Do I have any other Z to the second? You probably say no, right? This is the only Z to the second you have. And if that's the only Z to the second you have, you bring down the Z to the second, which is 2Z to the second, okay? So this is all you do, is because you don't have any other Z to the second, we just bring down the 2Z to the second. And similarly, right? Similarly, I don't have any other Z. This is my Z, and this is Z to the second. They are unlike term. I don't have any other Z. I just bring this item down, which is I have 7Z. What is my last like term? My last like term is, hopefully you guys see that I have a -9 and a -17. And a negative, they have the same sign. And if they have the same sign, I need to add them and kept the sign. And in this case, the sign will be negative. So I add them up and kept the sign. I will have a -26. And as you can see, there are no other like term. This is, I have Z to the third, Z to the second, Z, and a constant is just Z to the third, Z to the second, Z, and a constant. And as you can see, this thing here is a third degree polynomial, right? The highest degree is this item here. The highest degree, we say that this is the third degree polynomial, okay? And the leading coefficient will be 12. That will be your leading coefficient. It's not the biggest number, it's just the number in front of the biggest degree. That will be your leading coefficient, okay? But let's go, let's zoom out, and let me ask you guys any particular question in A, B, C, or D. It's so colorful, huh? Any question here in terms of A, B, C, or D? And hopefully, many of you see that this is just a repetition of chapter 2. And the only thing different is, like I say, they instead of say combine like term, they tell you that we need to add, we need to subtract, okay? Any question here? Well, if you don't have question, let's take a look at the example 2. And example 2, you probably will see this item here. And to relate us back to our chapter 2, remember what is the unique thing about this word form, right? They ask you to subtract this item. Whatever this item is, we need to subtract that from this item, right? So how do we subtract this? Well, we know that subtraction is, the operation is subtraction, and that's what we have, right? I need more room. Give me 1 second. Subtraction, I know the operation is subtraction, but remember, reminder that the keyword is subtract this from that. And if you remember from chapter 2, anything after the word form, reminder that we have to move it in front of the operation. So in this case, 13x plus 1 subtract the ax minus 7. If you remember in chapter 2, that's what we need to do, is anything subtract something from something, meaning anything after the word form is the more dominant, and we need to take that, we need to subtract the other thing from that, right? So when you set up this item, make sure that anything after the word form have to go in front of the operation, and the other one will go behind the operation. Because once you have that, the difference is because of this subtraction, or because of this operation of a negative, we need to change the sign. And if you change the sign, you can see that my problem will be 13x plus 1 minus ax plus 7, because a positive become a negative, and a negative become a positive. Negative, negative, positive. And once you see this, do you agree? And again, you can disagree, but you will be wrong, right? Just kidding. Do you agree that 13x take away ax, those are my like term, which is 11x take away ax, that will give me 5x. Again, it's not 5x squared, you just subtract the number and kept the variable. And lastly, right, we have 1 added to 7 and 1 added to 7, that will give me 8. So in order for you to come up with this answer, ladies and gentlemen, in order for you to come up with an answer, you have to make sure that you can recognize that subtract something from the other is when you set up the operation is subtraction, but the order of the item need to be swapped, okay? So question here in terms of A. And if you don't have the question in A, you can see that B is very identical, right? How identical? Well, the item is different, but this is what I have. My operation is subtraction. I just need to take something in the back and move it to the front in the sense that I have a y to the second minus 18, and then the item here 4y squared minus 9y plus 12. And that is what you guys need to remember, is when you subtract something from something, the from item have to go in front of the operation. And now this is what we have. Because we have 3 items in the second parenthesis, we have to be fair and distributive to every single item. So in front of this item, I have ay squared minus 18 still stay the same. Positive, this become a negative 4y squared. A negative become a positive 9y, and a negative 12. Everybody see that? And once we have this item, hopefully you guys see that all we have is combined like term. What are my like term? My like term is the ay take away 4y. And the ay take away 4y, that will give me ay squared take away 4y squared, that will give me 4y squared. I do not have any other y except this 9y. So all I need to do is bring it down. I have 9y. And hopefully you guys see that we have a negative 18 and a negative 12. A negative and a negative, same sign, we add and kept the sign. So the answer would be negative, and we have 30. And in this case, this is what we have: 4y squared plus 9y minus 30. And this will be our second degree trinomial with the leading coefficient of 4. So question with example, and we did this already, it just bring it back in terms of the word form to remind you that if you have subtract something from something, you need to kind of reverse the operation, okay? Question, ladies and gentlemen. And that is all 5.2. Addition is easy, subtraction is still easy. It's just that you need to change the sign before you can combine them, okay? But in short, to add or subtract, your goal is you just combine like term. And how do we know the like term? The exponent have to be the same. Your variable and your exponent is the same. Those are your like term, okay? Now, let's take a look at 5.3. How do we multiply? And 5.3, this is all we have is multiply polynomial. So how do we multiply polynomial? Well, to multiply polynomial is basically the same thing you've been doing. Is if you have a parenthesis, you want to distributive them in. But if you don't have a parenthesis, let's take a look at A. If you don't have a parenthesis, how do we go ahead and simplify or multiply this problem? Well, if you want to multiply this item here, all you need to do is take the constant, times the constant, and the variable times the variable. Meaning this is all we need to do is take 3 times 7 and x to the 5th times x to the 2nd. Again, do we know what 3 times 7? Please do not tell me it's 10, right? Reminder, your rule of multiplication is the same before. 3 times 7 will give me 21. And this item, if you remember from yesterday, if we multiply the same base with a different exponent, all we need to do is we need to add the exponent. And 5 plus 2, that will give you 7. And this is the only time that your exponent is increased is when you multiply. Okay, last time, why the exponent did not decrease on the previous 7 problem we have, the reason is we add or we subtract, okay? So in this item here, this is all we're doing is we can arrange the term. Reminder that multiplication is commutative and associative, meaning it doesn't matter how the grouping is or the order, right? 3 times 4 times 5 is the same as 5 times 3 times 4 or 4 times 5 times 3. Doesn't matter what the order, they are associative, meaning you can multiply different, but the result is still the same, okay? So in a sense, let me ask you A. Do you have any question in how I have 21x to the 7? And if you don't have question with A, B is the same, right? B, now, if you look at A, this is what they tell you is we have a monomial. We have a monomial times a monomial. And if we have B, what does B tell you? B tell you that if we have a monomial times a binomial. So if what is the monomial times a binomial? Sure. Let me do B and C, and I will let you guys do I will let you guys do D in your own. It's the same concept, but let's do B first, which is how do we do this item? For me, I like the distributive property. So if you look at this item here, it's basically tell you to take this item and distributive in here and distributive in here. So technically, ladies and gentlemen, technically, this is all we doing is we take the phi x to the second and we multiply that to the ax. And again, because of this minus, I take the phi x to the second and I multiply that to my phi. Okay, so basically that's all we're doing is we take the phi x and we distributive into that. And if you can see, all we did was we turned into 2 of this problem here, right? We just turned into 2 of that problem because now we know that all we need to do is what is phi x to the second times ax. And later on, you will see that I won't write it this way. I just write it this way one time to show you that technically this is all we're doing is we convert this item into that. And we know that phi times 8 to give us 40, x to the second times x to the first, right? 1 power to give you x to the third. And what is phi times phi? Phi times phi, that will give me, phi times phi, that will give me 25. And I have 25, I bring down my x squared. So in the sense that when you distributive, when you multiply, this is what you have, which is 40x to the third minus 25x squared. I see that we distributive 5 times 8 will give me 40, x to the second times x to the 1, because if there's no number, reminder that is to 1. So 3, because 2 plus 1. And 5 times negative 5 to give me negative 25, and bring down my x squared. So question here in terms of A or B. And vice versa, what happens if we have a monomial? If you look at this thing here, we have a monomial times a trinomial. What is the case here? Same scenario, same case. All you need to do is take this item and distributive into every single term. All you need to do is take that item on the outside and distribute it to every single term. It's just that now you have to keep the negative in as a variable or as a number instead of multiplied by a positive. So you can see, and again, if you want to, if you in doubt, you can always put a 1 here, right? X by itself is just x to the 1. So looking at this thing here, do you agree that negative 6 times 1 will give me negative 6? X to the 1 times x to the second will give me x to the third, right? Because all we do is we add the exponent, we kept the x. And similarly, a negative times a negative, that will give me a positive. 6 times 9 to give me 54. An x to the 1 and x to the 1, that will give me x to the second. And lastly, negative 6 times 2, negative 6 times 2 to give me a negative 12. Bring down my x. And ladies and gentlemen, this is all that you can do. Why? Because there are no like term. There are no like term because x to the third, x to the second, and x, they are all unlike term. And like I say, this will be a third degree trinomial. Okay. So that is all there is in 5.2. In 5.2, this is all they have, or all they tell you to do is we take this item and we multiply, and to multiply, we need to distributive them in, okay? So first of all, question with A, B, or C here. Question with any of A, B, or C. So if you don't have question with A, B, or C, let me ask you guys to try D for me. See if you can do D. And again, ladies and gentlemen, if the reason why I draw this arrow is to remind you that you need to distributive into every single item. I do not draw an arrow to make my problem look nicer, okay? You have to distributive in all 3, so make sure see if you can distributive into this 3 item here. So if you do this, again, basically reminder that all we're doing is we take a constant, time the constant, and then we add our exponent together, right? So if you do this thing here, hopefully you guys see that 7 times 9, that will give me 63. And x to the 4 added to 5 more x, that will give me x to the 9 power. Do you agree that we multiply, we add the exponent? So 7 times 9 to give me 63, x to the 4 added to x to the 5th, or multiply x to the 5th, that will give me x to the 9. Basically, I just add the exponent. And similarly, 7 times 2 to give me 14, x to the 4 increase 2 more, that will give me x to the 6. And lastly, 7 times a negative 8 will give me a negative 56. And I need to bring down my x to the 4, right? Because there's no x here, so I do not increase anything else. I just take the negative 8 times the 7. So question here, in terms of this answer that we have for this particular problem. And like I say, I don't write this breakdown. I just break down this way to show you the first term, that technically that's what we do. But again, you know, it's easier to see that all you do is you take the constant, time the constant, and the x, if you have the same x, you increase them. Question with D. Question with A, B, C, or D in this particular item here. Any question at all? Is it doable? Cross my finger, right? It's pretty doable, you know, combine like term when you add or subtract, and when you multiply the constant times the constant, the x times the x, okay? So let's take a look. If you don't have question, let's take a look at the last few items. So what we did earlier were a monomial times a monomial, a monomial times a binomial, and a monomial times a trinomial. That's what the previous 4 problems did, right? What is the difference between example 2? Well, example 2, we have a binomial times a binomial, right? We have 2 terms here. We have 1 term, 2 term, times 1 term, 2 term, which is we have a binomial times a binomial. So how would we go about to do this item here, ladies and gentlemen? All you need to do is, again, this one here, we told you, or I tell you to use the distributive, right? So distribution basically tell you take this item and you distribute it into the, because we have 2, we would distribute it into those 2, and vice versa. We have to take this item and we distribute it to those 2. Okay, so that's the idea, or that's the goal that we have here, is because we have 2 terms, we have to distribute it into both of the item, and we have to use both terms to distribute it. So let me use my color coding, right? So the first thing is I take the phi, this is what I have, is I take the phi x and I distribute it to the 7x, add it to the phi x, distributive to the 1. So everybody see that that's what I have. I take the phi and I distributive to the second 2 item, okay? And I have to do the same thing for the 2, and I take the 2, which is the 2 is positive 2 times the 7x, and then the 2 times the 1. But see that technically, that's what you do, is you take the first item, you multiply to the second 2, you take the second item and you still multiply to the second 2. And did we do this before? Did we do this item here in terms of the 5 times the 7? Do you agree that 5 times 7 to give me 35 and x to the 1 times x to the 1 to give me x to the second? And similarly, 5 times 1 to give me 5, which is those are my, when I took the 5 in, those are my 2 items. And secondly, I need to take the 2 plus, not 2 plus, 2 times 7 to give me 14, bring down my x, and 2 times 1 is 2. The only thing different between this problem and the previous problem is, ladies and gentlemen, you do have like term. If you look at the previous 4 problem, you don't have any like term here. You have x to the 9, x to the 6, x to the 4, or x to the 3rd, x to the 2nd, or vice versa. You don't have a like term. In this case, for this particular problem, you do have a like term because you have a 5x and a 14x. Because those are your like term, you need to combine your like term. And how do you combine your like term? Well, you just add them up, right? In this case, we have 35x to the second, 5 plus 14, that will give me 19x, and I bring down my 2. So the difference between this particular trinomial, or not trinomial, when you have a binomial times a binomial, this is what you need to do, is we need to combine the like term. So because my like term is an x, I need to combine them and keep whatever I have. Okay. So question with A. 6y7. Let me do B on another page since I'm running out of room. 6y minus 7, y plus 12. So let's say if I have my problem 6y minus 7 times y plus 12, right? So if we were to have this problem, this is my B problem, 6y minus 7 and y plus 12. So how would we go about to do this problem? Again, same idea go, we need to take this item here, the 6y, and we need to distributive into this item here. And you can do this, which is 6 times 1, right? This is assumed to be 1. 6 times 1, that would give me 6. Y times y to give me y squared, right? And 6 times 12 to give me 72. And bring down my y. Everybody see where my blue ink come from. 6 times 1 to give me 6. 6 times 12 to give me 72. Again, y times y to give me y squared. I just bring down my y. So that's my blue ink. And now my red ink, I need to take this 7 and distributive to those two, which is negative. Reminder, we have to use them the negative because the sign in front of the number is the number itself. Negative 7 times 1 will give me negative 7, bring down my y because my y is right here. And negative 7 times a positive 12 to give me a negative 84. So everybody see where my red ink and my blue ink come from, or how I got the red ink or how I got the blue ink. Again, the blue ink is I took the 6 and I distributive to the second 2 or the second parenthesis. And the red ink, I took the negative 7 and I distributed to a second parenthesis. And now if you take a look at this thing here, the only thing the only thing that you need is, again, we don't have any y squared other than the 6y. We don't have any constant other than the 84. The only like term we have is this item here. And all you need to do is you need to take 72 minus 7, and 72 minus 7, we kept the sign of the larger number, so this item will be positive. 72 minus 7, this thing will give me 65. Bring down my y, and this will be my answer. So this is what our objective for 5.3. When you multiply a binomial times a binomial, 2 by 2, right? A binomial times a binomial, this is what we have. And again, this will be a second degree trinomial, and your 6 is your leading coefficient. Question in terms of B here. Let's do C, and then I will ask you guys to do, well, let me ask you guys to do C for me, and then I will mention about a FOIL method in a bit. So C is right here. So see if you can do C, distributive them out. Distributive them out, you know, should be, remind yourself, if you want to, basically you take this item and you arrow them out. You take this item and you arrow them out. Okay, so see if you can do C, arrow this thing out, distributive them in. So if you do this, hopefully this is what you guys have, right? 4 times 2, do you agree that that will give me 8? And the z times the z to give me z to the second power. And a 4 times a negative 3, a 4 times a negative 3 to give me a negative 12. I bring down my z. And question on where I have my blue ink, right? I took the 4, I multiplied to the second parenthesis. And look at this thing here. The book also tells you that you can do this. And since that my screen is a little bit short, I can write it this way, ladies and gentlemen. Do you agree that we have a negative 9 times 2, a negative 9 times 2 to give me a negative 18, bring down my z, and a negative times a negative to give me a positive 27? Because, you know, one way is, if you do it this way, they tell you that you can write, instead of write horizontal, because, you know, I run out of room, I write a little bit big, I run out of room, I can write vertical. And my z, do you agree that my z is the same tone, in the sense that z and z is the same light tone? All I need to do is combine that, right? So this way, as you can see, this is all we did was, we just basically tell you the blue ink, I took the 4, I timed the second parenthesis, and the red ink, I took the negative 9 and timed the second parenthesis. And once I have that, do you see that all I need to do is bring my a, z to second, because there are no light tone other than that. And what is negative 12 and a negative 18? Well, they are both negative. Remember, we need to add them and cap the sign. In this case, my sign will be negative, right? And 12 plus 18, that will give me 30 z. And lastly, I need to bring down my 27. So this, ladies and gentlemen, is your answer, right? So instead of write horizontal for you know, as you can see, my part A, I write horizontal, and I run out of room, so that's why I have to do B on another page. But if you run out of room, you can write vertical like this. It's the same. It's just that make sure that you multiply correctly. Okay. So regardless how you write horizontal or vertical, just make sure that if you write your vertical, your like term is in the same location as one above the other. Okay. Question here in terms of A or in terms of C. Again, B is on the other page. So any question here with A or C? How to multiply binomial times a binomial. And if you don't have question, that's one way to do it. The other way the book tells you is there is a FOIL method. A FOIL method is basically tell you this item here, ladies and gentlemen. The FOIL method is tell you that you take the first term. This is your first times the first. The FOIL method is the first times the first, and then the outside number times the outside number, or the inside number times the inside number. That's what FOIL is: first times first, outside times outside, inside times inside, and last time last. So in the sense, the FOIL is just the same as what you've been doing. The only reason why I don't focus on the FOIL a lot is, you can just put the error, you can error them out and you still get the same result. Instead, remember what FOIL is: first time first, outside time outside, inside time inside. You can see that we can disregard this item and we can just say, well, if I have a multiplication, which is in this case, I have multiplication, all I need to do is take this item here, my first item, times the first item, that's the first time the first, the outside times the outside, that's what your FOIL FO, and then you take the inside times the inside and the last times the last. So basically it's the same as before. It's just that now they want to give you a name so that you can easily correlate. But the one thing is I don't mention it a lot because next week, when we do a trinomial, a binomial times a trinomial, we cannot use FOIL. Okay, so for me the easiest thing is just use the distributive property or distribution here and just go ahead and distributive as you've been doing. And if you look at this problem or this item, the problem is just identical, right? You have 2 by 2, you have 2 item times 2 item. All you do is you arrow them out. And if you arrow this item out, you can see that 2 times 9 to give me 18, and x times x to give me x squared. And 2 times -10 to give me -20, bring down my x. And like before, nothing changed, right? Multiplication here, as you can see, nothing changed. And 7 times 9 to give me a positive, 7 times 9 to give me 63, bring down my x, and 7 times a -10 to give me -70. So again, this is all that you've been doing, and it does not change. It does not change if you use a FOIL or you use the distributive property or distribution here. Okay, so looking at this thing here, hopefully you guys see that 18x to the second is still 18x to the second. One of them is positive, the other one is negative. Same sign I add, opposite sign I subtract. And if I subtract this item, I would get 43. And again, which is the sign of 43? Do you agree that 63 is bigger? So the 43 will be a positive 43. And I bring down my -70. So as you can see, FOIL is the same: first time first, outside time outside, inside time inside, last time last. Is the same idea as you using your distributive property. Okay. So looking at this item here, question in terms of example 1 or example 2, which is example 1 and example 2 is the same example. It's just that they mention FOIL. I don't like to use FOIL a lot. That's why I tell you that you can always arrow them out, which is draw your arrow. and then see what you can multiply. Okay. Question here, ladies and gentlemen, question with A. Well, I would let you guys attempt B and C. We can pick up B and C next time. I will let you guys do B and C, and then we can check our work in the next class. So for now,